No one has been able to replicate this. This hole was drilled into solid granite over 4,000 years ago. Look at the interior walls, smooth, circular, consistent from top to bottom. These spiral grooves suggest the drill bit advanced downward through the stone with every rotation, cutting deeper with each pass. Granite is harder than steel. It ranks 7 on the Mohs hardness scale. A copper tube ranks 3. And yet, across Egypt, these holes appear again and again, in granite, in quartzite, in basalt, with a consistency that demands a serious answer. Egypt is officially classified as a Bronze Age civilization. Copper tools, stone pounders, wooden sledges, sand as an abrasive. So how did they do this? Let us be clear about what is not in dispute. Copper combined with abrasive sand can cut granite. That has been demonstrated in modern experiments. Dolerite pounders can fracture hard stone through sustained impact. Organized teams of workers can quarry, transport, and position blocks weighing dozens of tons. Ramps, sledges, and lubrication explain large-scale movement. All of this is accepted. The tools existed, the labor existed. The organizational capacity of ancient Egypt was extraordinary. What is in dispute is not whether these tools could work, it is whether they explain everything we find. Because when we look closely at Egypt's hardest stonework, the granite, the basalt, the quartzite, the evidence begins to separate into 2 very different categories. Start with the drill holes, because they are the most testable evidence in all of Egyptian archaeology. Core drilling works by rotating a hollow tube against stone, while feeding abrasive material into the cut. The tube removes a cylindrical plug and leaves behind a clean cavity. We see this exact geometry across Egypt, in granite blocks, in quartzite surfaces, in museum pieces pulled from sites spanning hundreds of years. Now, experimental archaeologist Dennis Stocks demonstrated that copper tubes with sand can drill granite under controlled conditions. That experiment is real. It works. But there is a gap between proving a method is possible and proving it accounts for what we actually see. The Egyptian examples show depth, symmetry, and surface consistency that have not been replicated at equivalent scale. Not once, not in any published experiment. The question is not whether copper can cut granite. The question is whether copper can cut granite like this deep, this clean, this many times. And these are not rare anomalies. They appear at site after site. Repetition implies process. Process implies method. If this were a one-off, we could call it an outlier. Dozens of identical results is a production signature. Now scale this up dramatically. Beneath Saqqara, the Serapeum tunnels extend hundreds of feet underground. Inside them sit massive granite boxes. Each one weighs approximately 70 tons. The lids alone weigh around 30. Run your hand along the interior and the surfaces are extremely flat. The corners are controlled, slightly rounded with geometric precision. The lids seat against the base with tight tolerances. These are not rough containers. These are precision forms in hard stone. And there are more than 20 of them. Shaping granite to this level of flatness with copper tools and sand is theoretically possible. Nobody disputes that. But the scale here is industrial. The tolerances are deliberate. And the repetition across more than 20 boxes does not suggest isolated craftsmanship. It suggests standardized production. Some boxes were never finished. They sit rough-shaped, halted mid-process. Lids were separated and left behind. Work stopped abruptly. We do not know why. But the interrupted sequence tells us something. This was an ongoing operation, not a one-time project. Now here is where it gets interesting, because not all granite boxes in Egypt are the same. Some, attributed to known dynastic periods, are functional and clearly hand-worked. Hieroglyphics are carved directly into the surface. The finish is serviceable. The tool marks are visible. You can see the effort. Then there are the Serapeum boxes, larger, more refined. Interior planes that reflect light evenly, no inscriptions on the original surfaces. When hieroglyphics do appear, they look hastily added, sometimes poorly aligned, sometimes scratched into an already polished face. These are 2 completely different levels of manufacturing. They exist in the same civilization, in the same historical record. That contrast is not speculation, it is visible. Step outside the Great Pyramid. Beneath your feet lie basalt paving stones. Basalt ranks 7 on the Mohs scale, significantly harder than limestone. On some surfaces, long, straight grooves appear. If random pounding produced these, we would expect irregular impact marks, fractured edges, chaotic scalloping. Instead, the cuts are linear, deliberate, parallel. The physical record shows controlled cutting behavior, consistent with abrasive sawing. At the 2nd and 3rd pyramids, granite casing blocks still survive, and on some of them, you can see something remarkable. Later quarrying attempts, where someone tried to remove these blocks centuries after they were placed. The chisel marks are crude, uneven. They clearly struggle against the hardness of the granite. Now compare that to the original shaping of the same blocks. Controlled surfaces, clean geometry. The contrast is stark. Whoever originally shaped these blocks had a fundamentally different capability than those who came later and tried to cut them apart. This is not imagination. It is direct comparison on the same stone. At Saqqara, archaeologists discovered over 40,000 hard stone vessels beneath the step pyramid. Symmetrical, thin-walled, some with walls less than 2 millimeters thick, carved from tough metamorphic materials like schist and diorite, stones that rank 6 to 7 on the Mohs scale. A handful of masterpieces could be attributed to elite artisanship. 40,000 indicates systematic production. The symmetry of these vessels implies rotational control, something beyond freehand carving. The sheer volume implies a method that could be repeated efficiently. Whatever that method was, it has not been identified in the conventional toolkit. At Abydos, the Osirion sits partially submerged beneath later dynastic construction. The lower structure is built from massive granite and quartzite blocks, some weighing over 100 tons. Above it sits later stonework. The difference is visible immediately. The upper construction is comparatively rough. The lower structure is clean, massive, and precisely fitted. On some quartzite blocks, horizontal cut lines resemble long saw passes. The stone behaves as if it was shaped with controlled, sustained motion, not incremental pounding. This is not one site. This is now the 5th site showing the same signatures. Giza, the Serapeum, Saqqara, Abydos. At what point does coincidence become pattern? In one museum example, a saw line appears to have drifted inward during lid separation. The drift weakened the structure and caused part of it to snap. The piece was abandoned. That detail matters more than it seems. It implies a long, continuous cutting motion through solid granite. Not pounding, not chipping. A single controlled pass that went slightly off course. That is a manufacturing error. And manufacturing errors tell us more about process than finished pieces ever do. When all of this evidence is viewed together, a pattern emerges. We see 2 distinct technological intensities in Egyptian stonework. One reflects clear hand tooling, incremental shaping, visible effort, integrated inscriptions carved into primary surfaces. This is recognizable Bronze Age work. It matches the tools we know they had. The other reflects large-scale hard stone precision, flat planes, cylindrical drilling, tight-fitting components, standardized repetition, and minimal decorative emphasis, as if the function mattered more than the appearance. This does not automatically prove a lost civilization. It does not prove advanced machinery. What it proves is that the physical record contains manufacturing signatures that have not been fully reconciled with a single Bronze Age narrative. The burden is not to speculate wildly. The burden is to demonstrate process. If the full range of these drill geometries, this surface flatness, and this scale of repetition can be convincingly replicated under Bronze Age conditions at comparable efficiency, then the conventional model stands complete. That experiment has not been done. Granite does not exaggerate. Basalt does not speculate. Quartzite records only what touched it. The tool marks are real. The tolerances are real. The repetition is real. And until the exact process that produced them is fully demonstrated at scale, the stone itself keeps the timeline under question. If you want to support deeper research and found this journey as fascinating as we did, subscribe to Ancient Epochs for more.